Okay, so for this example, we're going to go over a partial fraction decomposition in which we have repeated linear factors. So we have a rational function like this. Again, the degree in the denominator is bigger, right? So I can do the partial fraction decomposition. It is a quadratic, but it is a quadratic made up of two linear terms, right? The factors are linear terms that are the same, right? In this case, x plus 3. Right here, notice the difference from the previous one where, right, even if we had multiple linear factors, right, they were all unique, they were different. Okay, now here we're going to take a different approach. All right, now, as it turns out, the way we are going to do this partial fraction decomposition is it starts off the same, right? But here we kind of build up to whatever value this happens to be. Now, this is a squared, but this could be 3, 4, whatever, and we would take the same approach, right? Where we would increase here, this would be x plus 3 squared. All right, and if, for example, the value was 4 here, x plus 3 to the 4th power, right? If this was a 4, then the next term would be c over x plus 3 cubed plus d over x plus 3 to the 4th. All right, so that's how we would deal with any kind of repeated factors, right? We start by 1 and each step of the way, right? We still have a constant in the numerator, an a, b, c, leading up to however high that power is, right? However times it's repeated. And then from here, the steps are the same, right? So we would now multiply both sides by this x plus 3 squared. And here we get 7x plus 4. Here, one of the factors reduces, so we're left with a times x plus 3. And here they both reduce, so we get b, or simply just b. All right, and now we distribute that a. And we get ax plus 3a plus b. Right, and now we line up the terms to the corresponding terms on the left side, the 7x plus 4. Right, so a is the coefficient in front of the x coordinate, and you can treat everything that doesn't have a variable as just the coefficient or the constant term, right? So here we would have a is equal to 7. Excuse me, a little sloppy here. Here we have a is equal to 7, and we get 3a plus b equals to 4. All right, so this worked out nicely in my favor here. That one is right away, we get it solved. So now we go into the second equation, and we plug in what we know for a and solve for b. Subtract 21 from both sides, and we get b is equal to negative 17. So now we have a partial fraction decomposition here, where a is 7 over x plus 3, and here minus 17 over x plus 3 squared. Right? Or you can think of it, excuse me, as plus and then a negative 17 in the numerator, right? Either way works as well. Okay, so now that's how we would approach our repeated linear factors. Let's go over, another example where let's say that we had a combination of non-repeated and repeated factors and how we approach something like that. Okay, so let's say here we had, for example, 5x squared plus 20x plus 8 all over 2x x plus 1 squared equals to a. Well, actually, before we get into that, let's stop for a moment here. And a couple things that are different from the previous example, right? And even the previous examples that we did before. So here we have a constant, we have a 2 there. So what I would suggest here is don't worry too much about the 2 and here. Just worry about the factors that have our variables. In this case, I notice I see 2 factors, x and the x plus 1. Right? X is a linear term, non-repeated, right? It's only to the first power. X plus 1 is also linear, but it is repeated, right? Twice. So we can mix the techniques that we've learned here, right? For non-repeated factors, we could simply have a over x. And now for the linear repeated factor, we do what we did in the previous example. We start off with it being to the first power. Oh, excuse me. And then c, each step of the way we raise it 1 power. Okay. All right, so that would be the decomposition. So now I want to find the a, b, and c. Right, so we multiply through by the common denominator here, which is, here's where I'll bring in that factor of 2, x times x plus 1. Now in doing that, on the left side, we'll be left with the polynomial 5x squared plus 20x plus 8. Now here, I'm going to be mindful here just so I don't keep writing 2 all over the place. Everything is going to get multiplied by 2. So I'll just kind of hang on to that on the outside there. And now as I distribute, let's keep in mind which factors reduce each step of the way. So when I multiply by 2x, x plus 1 squared, that factor of x reduces. So I'm left with a x plus 1 squared. Okay. Here we'll have b. Right. One of the factors of x plus 1 reduces, but I still have a factor of x and a factor of x plus 1. And then for c, both of the x plus 1 factors reduce, and I'm simply left with a factor of x. Okay. All right, so it looks a bit overwhelming here. Let's start kind of distributing first. So always keep in mind that 2 is still out there. So here we'll have 5x squared plus 20x plus 8. And then here the 2, we'll have a, expanding this, we'll get x squared plus 2x plus 1. Here we'll have b, distributing that x squared plus x plus cx. Okay. All right. Excuse me. So now let's start grouping all the coefficients for the x squared, the x, and the constant, right? So let's start with the x squared. So notice we have an a and a b. And don't forget the factor of 2 on here. So we'll have 2a plus b for the x squared. Okay, and then for the x, all right, there's still a factor of 2 out there, and here we'll have 2a plus b. And also plus c. Almost forgot that one there. All right, and we have one linear term here, one constant, that 1 attached to the a, and don't forget the factor of 2 on here. So we get 2a. All right, so here, kind of lining these up here, we get 2a is equal to 8. 2a, actually here, let's go ahead and we can distribute that too. So we'll have 4a plus 2b plus 2c is equal to 20. And 2a plus 2b is equal to 5. All right. Okay, so here, working along the way here, let's give me some room here. All right, so here we can solve for a right away by dividing by 2. And we get a is equal to 4. All right, and now looking at the remaining two equations here, I think here solving the 2a plus 2b is equal to 5 is going to be my next step here. So we plug in for a, the number 4, 2b equals to 5, so we get 8 plus 2b is equal to 5, subtracting 8 from both sides. We get 2b is equal to negative 3, or b is equal to negative 3/2. All right. Okay then. Excuse me. Okay, so now we have our a and our b. The only thing that's left is to find c by plugging in here. For a, we have the value of 4. For b, we have the value of negative 3/2 plus 2c equals to 20. All right, so we get 16 minus 3 plus 2c is equal to 20. And we get 17, combining like terms, subtracting 17 from both sides is equal to 3. And we get c is equal to 3/2. All right, so now we have our constants a, b, and c. And that means we have our partial fraction decomposition here, right? We have 5x squared plus 20x plus 8 over 2x, x plus 1 squared. We get to be 4 over x plus negative 3/2. 16, 30. Excuse me. Got a little ahead of myself here. I'm not sure what I was thinking here. So here. Okay. Let me backtrack here. Okay. Okay. 16 minus 3 is 13. Subtracting 13, we get 2c is equal to 7. And then lastly here, this becomes 7 over 2. Okay. So x plus 1 here, and then 7 over 2 over x plus 1 squared. Okay, so again here I made a mistake here. We're kind of getting ahead of myself. 16 minus 3 is 13. Subtract 13 from both sides, we get 7 on the right, 2c on the left. Dividing by 2, we get 7/2. And now we have our 3 coefficients, and we have our partial fraction decomposition here. Okay, thank you.